Alright, so this video is going to be on distribution shapes. So real quickly, what we've done so far in the past, lesson 2.1, we talked about the difference between qualitative and quantitative data. Qualitative data was data that wasn't really a number, and quantitative data that could be evaluated with a number. We also talked about how if it is quantitative data, it could be discrete or continuous. And then in 2.2 we talked about displaying qualitative data with a frequency distribution or a relative frequency distribution. And as far as the graphs go, we did pie graphs and bar graphs that represented that qualitative data. And then in 2.3, which was our last lesson, we talked more about quantitative data, data that could be categorized by numbers. And so we talked about how we can categorize them with a single value. We can use limit categorization or cut point if it's a continuous scale. And then we can display this with histograms. Histograms are a lot like bar graphs, but bar graphs have spaces between them and histograms don't. Dot plots and stem and leaf plots. And so today we're going to be moving on to lesson 2.4, which is distribution shapes. So let's go ahead and get started with this. First thing we want to talk about is what is the distribution of a data set. So it's a table or graph or formula that provides the value of the observations and how often they occur. So it's any, like a stem and leaf can show you the distribution. A line plot can show you the distribution of a data set, but what we're going to specifically focus on today is the shape of that distribution. It's classified in three ways: the modality, symmetry, and skewness. And when we talk about modality, is, well, we'll get to that here in a second. This is an example. So if we take everybody's height and do a histogram of everybody's height, this is how many inches tall somebody is. 5 feet is 60 inches, so this would be someone who's 5 feet tall right here. And then 6 feet would be 72 inches, which would be up here. And so we're talking about this just kind of a bell-shaped curve. You may have heard that before. We're going to learn that this is a normal-shaped curve, but that's what the shape is. It's not like it's all straight across. Okay, this is one modality. In other words, there's one like peak in the data. And so if we talk about modalities, it could be either unimodal, where there's like one peak in the data like it is here. It could be bimodal, okay, which is what we have going on here, where there's actually two peaks in the data. This happens occasionally on tests in school, where we might have a lot of people that don't do very well, and then we have a lot of people that really do well, but not a whole lot of people in the middle, and that would be bimodal. And then we have multimodal, which would look something like this with several peaks in the data. And so most of the data that we're going to be talking about is unimodal. We'll have a peak in it somewhere along the graph. So then we're going to talk about the symmetric distributions. Symmetric distributions really involve three major types of shapes. One is bell-shaped. That's where it starts off low and it ends low, but somewhere in the middle it peaks and it goes back down. This bell-shaped is a lot of times called a normal distribution. We're going to talk more about that in a later unit. But here's what a bell-shaped curve would look like, or a bell-shaped distribution. Then there's a triangular shape, which is similar to a bell-shaped, except it goes straight up and straight down. It's not like there's a curve at all in the data. And then a uniform or rectangular distribution is where everything just kind of occurs the same. And that's what it would look like here. So we did the modality. We classify it based on symmetry, and then we're going to classify it based on its skewness. And so it's either going to be skewed right or skewed left. A lot of people get these backwards. So this is actually, there's more information to the left. There's more data points to the left. But there's a few points way over here to the right that skew all the information way to the right. This is called skewed right. It's like there's somebody pulling this end in that direction, and it's kind of stretching it out to the right. And if it's being stretched out to the left, then it's skewed to the left. And if so, it's kind of the opposite of where it's being jumbled. If it's jumbled to the right, like it is here, that means it's actually skewed to the left. And if it's jumbled here on the left of the graph, that means it's actually skewed to the right. All right. So then there's different distributions that are not symmetrical, J-shaped curves. And so this is an example of a reverse J-shaped curve. A J-shaped curve would be something that looks like this. It starts off like this, and as we go on, it gets higher and higher. So the difference between a J-shaped curve and skewed is that it doesn't come back down. You can see this comes back down, and then it goes back down. So it ends low, it starts low, and it ends low. A J-shaped curve starts out low on one end, here, if it's red, here if it's the blue one, and ends really high on the other end. And so that's a J-shaped distribution. So let's just take a look at some of these. This is a number of people in a household. And so suppose somebody did a survey, how many people live in your house? Several people here said 1 or 2 or 3 or 4 or 5, 6 or 7. You can kind of imagine as we get bigger here, this is going to be skewed to the right, okay? Because there's big families out there that kind of skew that information way to the right. But it is going to come back down here. We're going to have more people have 2 or 3 probably than even 1. It is unimodal because there's one peak in it. Okay, it's not like there's 2 or 3. And it is not symmetrical because it is skewed. So let's take a look at different types of populations, different types of data that we can look at. One is the population data, and one is the sample data. We talked about this before. As a matter of fact, if it's an inferential study, that's where you take the sample data and you apply it to the entire population, and you make those assumptions that it's representative of the entire population. And so we have data that can be, we can graph the entire population data, or we can graph the sample data. And so the distribution of population data is called the population distribution, or the distribution of the variable. Sometimes it's referred to the same thing, but it's the population distribution. And if it's just the sample, we call that the sample distribution. The population distribution is probably what we're looking for most of the time, but sometimes we make an inference that if we have a good sample, that it's going to apply to the overall population. So let's take a look at these. Here we have in blue, this is the population distribution. And then over here we have 6 different samples of this population. So we have the number of people in a household. We've talked about this graph already. But maybe in order to get that, they've done 6 different surveys. And in one survey, you can see that there's one person in a household 25% of the time. And here it's almost, this looks really close to this. But you can see there's a minor difference, like right here, there's a different than right here. You can see there's a bigger difference here. As a matter of fact, from 20 to 40 here, where this is a lot less. But you can see the basic shape is the same. They're all unimodal. They're all skewed to the right, even though you can see minor differences in the data that was collected. The shape is generally the same. And another thing that we probably want to point out is that the more numbers, the more units you have in your sample, probably the more accurate you're going to be as far as your distribution goes. And that's what this is saying here. For a simple random sample, the sample distribution approximates the population distribution. And the larger the sample size, the better the approximation tends to be. We're going to talk more about that in class. And that's what lesson 2.4 is about. And so homework assignment will be to finish lesson 2.4 in Math Excel. And hopefully we'll be in school on Friday and have a chance to go over all these assignments that we're doing. Good luck. We'll see you soon, everybody. Stay warm.